Hello everyone, my name is Anvita Bansal and we are back with another lecture from our SDE sheet. So we are going to start off with linked list topic. Let me show you the problem that we are going to discuss today. So from your SDE sheet, you can find this problem, find middle element in a linked list. So I'll just take you through the question that we have here. So this is what we are starting off with today. The first question of it, this, okay. Let me just check if I think we are live. Cool. I'll just pause this so that. Okay. So in this question, you are given a linked list, okay, of n nodes. You have to find the middle of the linked list, and if the linked list has even number of nodes, so the second middle is what you have to return. So I'll explain you the question. The question is pretty simple, very obvious. I'd say it forms the basics of your linked list. So the difference between these two is, see, these two, I mean, if let's say, assume it was an array, okay. So if it were an array and you had, let's say, n nodes, here it is 5, and you wanted to return the middle element of the array, what would you do? You can check, the length of an array you can get in O1 of time complexity, right? So whatever is the length, you will return the n by 2th index element from your array, right? That's just O1 of time complexity thing in an array. But in a linked list, when we talk about, right, so I think this is clear. We don't have to discuss this, but I just want to show you the difference, why and what are we going to do when it is a linked list. So in this case, when we have a linked list, that means we have nodes pointing to its next, we have nodes, right? And the pointers are there 3, 4, 5. So in linked list, can we access an element using an index? No, that's not how linked list works. It works via pointers. We can access an element through pointers only. Now tell me that you see that in this nodes, in these many nodes, the middle element is 3. I want to return 3. So method one way is simple as what I told you above. What can you do is, since you do not have indexes here in linked list, what you can do is you can take a node which is, let's say, a temp node, which will be traversing through each of the nodes in your linked list. And while it is traversing, that means when temp reaches here, when it is equal to null pointer, that time, by then you will have the count of all the nodes you have. Let's say I am taking a count, int count, which will be incrementing every time you are traversing through every node. So when I'm starting my node temp from head, okay, this is your head pointer, right? This is your head pointer. When I start from here, I'll go until while my temp is not equal to null. What I am doing count plus plus, so that I can know what is the total number of counts, and moving my temp to the next pointer, right? So by this when I'm doing while, in this is a while loop, okay, while this thing. So when my temp reaches here, when my temp is at null pointer, by that time count is what it started. Let's say your count started from what, when you are initially at this head pointer. You can do it either ways. Let's say I initialize my count to 0. When you are here, your count becomes 1, then your temp reaches here, then your count becomes 2, then 3, 4, 5. So finally your count is 5. Now you have 5 number of nodes. So now what is the middle of this count? That is 5 by 2. That means you will get 2. So basically you want to get the node which is 2 at distance of 2 from your head node. So what you can do, you can take one more loop according to your counter. You can, let's say, int anything, it can be anything, any iterator, okay, int I equal to 0. So while I is not equal to, or I is less than this count divided by 2, you can say new count, nc, okay. While I is less than nc, what you are doing, again, let's say you have taken a new node, temp node, which is pointing to head. So you do temp t equal to t dot next, Okay, and each time you're incrementing the count of I. So how is it helping me? I am using this another loop. After this loop, I am using another loop to reach till n by 2th, that is this count by 2th index, so that I can directly return that node. So for I equal to 0, I was here. For I equal to 1, I will be here, right? And temp will be here, I 1. When temp is here, I becomes 2. When I, one second, you can right now your temp is here. This thing you can do, I'll just see. Temp is here, your I becomes, initially it was 0, now I is 1, and temp is here. Now what is your I? This is I. Now your I temp comes here and I becomes 2, while I is less than nc. Now you know that you will come out of this while loop when your I reaches at 2th index. So temp is pointing to which node, you will return temp dot data. That's what you have to return. This is one approach. What we have done here, basically we use two loops. One to find the total length, number of nodes. Okay, I'm not sure if you're given n. No, you're not given n here. Okay, so that n you will have to calculate. That's what we are doing. Second loop we are doing to reach till n, whatever n you got. Let's say n is the number of nodes, n by 2th index node. Okay, and you will return it. Now you must be wondering, what if it was a linked list with even number of nodes? So if it was an even number of nodes were even, in that case also, see, 4 by 2, or you can 4 by 2 is what, 2. So according to your question, you have to return the second middle element. So if I initialize my I at 0, I want to return 4 divided by 2, that is 2th index node. So 0, 1, 2, I will be returning the exact node I want to return. So this is one way. But see, we can optimize it, although it will take O of time complexity only, because this is the loop after I am done with this loop. So these are two parallel loops. Okay, fine. But how can I optimize it? See, in this question, I can do in exactly one pass. That was also O of time complexity, but I was taking an extra pass to reach till n by 2th index. How can I do this question in exactly one pass? So for that, we can do one thing. We can take a slow pointer. Let's say that is node slow, which is starting from head node. Then there is another node fast, which is your actually fast. Basically, I am going to use this method 2 will be your 2 pointers method. Method 2 will be using 2 pointers, where I am taking slow and fast pointers here. What is my aim here? I'm not saying it's very intuitive thing, but yeah, it's not difficult, not at all. Just that you need to understand what we are doing here. According to this question, whenever there is an even node, I want to return the second middle element, and in case of an odd number of nodes, exactly the middle element will be returned. So what I'm trying to do here is that every time, first of all, I am iterating over these nodes until your fast node becomes equal to null. Okay, so fast will be moving with the speed of fast.next. That means not fast.next. What is the meaning of this slow and fast pointer here is that, let's say slow is pointing here, fast is pointing here. For each iteration, my fast is going to skip one node and move. Basically, it is going to be point at 3 in the next iteration, whereas slow will go one by one. That means slow will become slow.next and fast will become fast.next. The reason behind this is, you can say I am moving fast by the speed of 2 and slow by the speed of 1. The reason is, by the time my fast will reach the end of the node, or it becomes equal to null, the slow will be present exactly where I want the node to be returned. I'll show you through an example so that you will understand it better what I am trying to say. Let's take two examples. 1, 2, 3, 4, 5, 6. This is one example. Another one I'll take of odd number of nodes. Okay, so I'm starting off with slow and fast pointer at head. This is your head node for both the cases. Okay, so start moving your slow and fast pointers, fast by 2 nodes and slow by 1 node. So for the next iteration, my fast will be pointing to this node and slow will be pointing to the next node. For the next iteration, my fast will skip 1 node and reach till here, directly fifth node. So fast will be pointing here and slow will go to the next node. Okay, slow comes here. Now for the next iteration, your fast becomes null. This is your null pointer. Okay, so fast reaches here and slow reaches here. Now you will have to stop your loop. This is the end of loop because fast is already reached the null node. Okay, not null node, fast is already null. Now you see where your slow pointer is present. Your slow pointer is present at the second middle element of this linked list. See, these two are the mid elements of this linked list. The second one is 4, so that's exactly where slow pointer is present. Let's do the same thing for odd number of nodes. This is your slow, fast at head. For the next iteration, slow comes here and fast will be directly at 3. For the next iteration, when slow comes here, fast will go directly at 5th index. Now would you try to do any more iterations? No. This is where you know whenever your either your fast dot next is null, if this is the case, or your fast is itself pointing to null pointer. These both are the cases when you have to stop your loop, and that's all. That means wherever your slow pointer will be, when you return that node, it will be the middle element according to the requirement. Okay, so let's quickly start with the code. Okay, cool. So let's quickly code it. Very basic and simple question. So node slow, I'm going ahead with the second approach. Equal to head pointing to head, node fast pointing to head. Okay, and I am keeping a check while if any of these two conditions fail, that is where I know that my slow is present at the right position. What are those two conditions? First is that my fast should not be equal to null, and the second case is fast dot next should also not be equal to null. If any of these conditions is not true, that means I have to come out of the loop and return my slow pointer. How am I moving these pointers? Fast becomes fast dot next. Okay, and slow is slow dot next. Then you return slow pointer, slow, and you have to return integer. So that means slow in itself is a node. So node consists of data, and consists of data in the form of, this is data and the other one is the pointer itself. So slow dot data will be the value that I will have to return. Fine. So that's all about this question, and we are doing it in exactly one pass, that is taking O(n) of time complexity and no extra space, so O(n) of space complexity, and that's all about this question. So see you all in the next lecture. Till then, take care. Bye bye.